How do you teach a robot right from wrong? It's a question straight out of a sci-fi movie, but it's also something we'll have to grapple with a lot sooner than you might think. Take a self-driving car that has to choose between hitting a child in its way or slamming its own passenger into a barrier. Or imagine a rescue robot that detects two injured people in the rubble of an earthquake, but knows it doesn't have time to save both.
How does that robot decide which of these people to try to save first? That's something that we as a community actually have to figure out.
It's a moral dilemma, which is why a team of scientists is attempting to build moral robots. If autonomous robots are going to hang with us, we're going to have to teach them how to behave, which means finding a way to make them aware of the values that are most important to us. Matthias Scheutz is a computer scientist at Tufts who studies human-robot interaction, and he's trying to figure out how to model moral reasoning into a machine. But with morals, things get messy pretty quickly. Humans don't really have any concrete rules about what's right and wrong, at least not ones that we've managed to agree upon. What we have instead are norms, basically thousands of fuzzy, contradictory guidelines. Norms help us predict the way that the people around us will behave, and how they'll want us to behave.
Right now, the major challenge for even thinking about how robots would be able to understand and use moral norms is that we don't even understand very well on the human side how humans use, represent, and reason with norms.
The big trick, especially if you're a robot, is that none of these norms are absolute. In one situation, a particular norm or value will feel extremely important, but change the scenario, and you completely alter the rules of the game. So how can we build a robot that can figure out which norms to follow and when? That's where the Mali Lab at Brown University comes in. Researchers there start by compiling a list of words, ideas, and rules that people use to talk about morality, a basic moral vocabulary. The next step is figuring out how to quantify this vocabulary. How are these ideas related and organized in our minds? One theory is that the human moral landscape might look a lot like a semantic network, with clusters of closely related concepts that we become more or less aware of depending on the situation.
Our hypothesis is that in any particular context, a subset of norms is activated by the particular objects and symbols and general knowledge we have about that situation. That activated subset of norms is then available to guide action, to recognize violations, and allow us to make decisions.
The key here is that the relationships between these subnetworks is actually something you can measure. Male starts off by picking a scenario, say a day at the beach, and asking a whole bunch of people how they think they're supposed to behave. What are they supposed to do? And what are they absolutely not supposed to do? The order in which participants mention certain rules, the number of times they mention them, and the time that it takes between mentioning one idea and another, those are all concrete values. By collecting data from enough different situations, it's possible to build a rough map of a human norm network. In the future, a robot might come equipped with a built-in version of that map. That way, it could call up the correct moral framework for whatever situation's at hand. But even if that robot could perfectly imitate a human's decision-making process, is that something we'd really want? Molly suspects that we might actually want our robots to make different decisions than the ones we'd want other humans to make. To test this, he asks his research subjects to imagine a classic moral dilemma. Picture a runaway trolley in a coal mine that's lost the use of its brakes. The trolley has 4 people on board and is hurtling toward a massive brick wall. There's an alternate safe track, but a repairman is standing on it, and he's oblivious to what's happening. Another worker nearby sees the situation. He can pull a lever that would switch the train onto the second track, saving the passengers in the trolley, but killing the repairman. He has to choose.
So the fundamental moral dilemma is, are you willing to intervene and kill one person to save 4? Or are you not going to intervene and let, as some participants say, fate take its course, and then most likely these 4 people will die?
Molly presents the scenario a few different ways. Some of the participants watch a human make the decision, some see a humanoid robot, and some see a machine-like robot. Then, he asks participants to judge the decision the worker made. Generally, participants blame the human worker more when he flips the switch than when he does nothing. Apparently, watching another person make a cold, calculating decision to sacrifice a human life, even if it's to save other lives, makes us kind of queasy. But evidence suggests that we might actually expect a robot to flip the switch. The participants in Molly's experiment blamed the robot more if it didn't step in and intervene. And the more machine-looking the robot was, the more they blamed it for letting the 4 people die. There's one more interesting twist to this. If the robot or human in the story made an unpopular decision, but then gave a reason for that choice, participants blamed that worker less. And this is really, really important because it gets at a fundamental skill that robots are going to need: communication.
Please lie down.
Okay.
Back in Matthias Scheutz's lab at Tufts, they're working on that exact problem. They've programmed a little autonomous robot to follow some simple instructions. It can sit down, stand up, and walk forward, but they've also given it an important rule to follow. Don't do anything that would cause harm to yourself or others.
Walk forward.
If the researcher gives the robot an instruction that would violate that rule, the robot doesn't have to follow that instruction, and it will tell you why it won't.
Sorry, I cannot do that as there is no support ahead.
Please walk forward.
But it is unsafe.
The researcher can then give the robot new information, and the robot will update its understanding of its little world and decide on a different course of action.
I will catch you.
Okay.
Please walk forward.
Okay.
This communication is essential because moral norms aren't fixed. We argue and reason about morality, and often we learn from each other and update our values as a group. And any moral robot will need to be a part of that process. We're still a long way from building a truly moral robot, but these studies could be the very first steps.